Hello, welcome to my channel where we talk about product intelligence, specifically AI product management. And in this episode, we're going to talk about artificial intelligence versus machine learning versus deep learning. If you take a look at this image right here, right, we see that machine learning is a subset of artificial intelligence and deep learning is a subset of machine learning. That's accurate, but what does this actually mean? Let's start with AI. The goal of AI is to make computers think intelligently like humans. But what is intelligence? It's a big, complex idea that spans pattern recognition, creativity, and emotional intelligence, and much more. Humans have built up intelligence over time through evolution, but when creating intelligent systems, we've started with the easiest part to quantify: pattern recognition. That's because things like creativity or emotional intelligence are much harder to measure. Now, I've crossed out generative AI for this episode for two reasons. Number one, I'm still learning it and I don't want to talk about something I don't know too well. And number two, this channel isn't about reaching or teaching PMs how to leverage AI to become better at their jobs. This channel is all about giving you the skills to create and launch AI products using the product development lifecycle. Now, don't worry, we will get to the generative AI in later episodes, but we'll build up our foundational knowledge so that you will feel comfortable picking up any new tool in the future. So, AI has been around since the 1950s, but it's only now becoming a buzzword for two reasons. Number one, infrastructure. We now have the computational power to build large scale AI systems. Tools like ChatGPT require staggering levels of computation, something that wasn't possible decades ago. And number two is accessibility. Tools like ChatGPT make AI accessible to non-techies, or it's no longer just a tool for researchers and developers, it's something anyone can use. At its core, AI is an umbrella term for programming computers to recognize patterns and react. Early AI systems relied on rule-based programming like if-else statements, and today AI can do much more, like detecting objects in pictures or even writing essays. So we talked about artificial intelligence, but what's machine learning? So AI is the goal, and ML is one of the methods to achieve that goal. ML enables machines to learn from data without explicitly programming all the rules. In rule-based programming, humans define all the rules and the computer applies them to a dataset to produce an output. Now in machine learning, we give the machine a dataset and it learns the patterns in that data to define the rules itself. This is powerful because computers can now recognize patterns at a scale that humans can't. For instance, humans can tell a dog from a cow after seeing just a few examples. A computer, however, doesn't understand the concept of a dog or a cow. Instead, it analyzes pixel patterns, shapes, colors, and then it assigns values to these features. The real advantage of machine learning is the ability to process huge datasets with hundreds or thousands of features, things no human brain could handle. So there's various types of machine learning, but there's three main types of machine learning that I want to talk about, right? So there's a supervised learning technique. So you provide labeled data, example house prices, based on features like size and location. The model learns to map inputs to outputs. Unsupervised learning, you give the model unlabeled data and it finds hidden patterns. Example, grouping customers into segments based on purchasing behavior. Reinforcement learning, the model interacts with an environment and learns through feedback, rewards, or penalties. Example, training a robot to walk or teaching AI to win at chess. And I know that sounds a bit abstract, so I'll give you three examples. Here, first, let's talk about supervised learning. With a supervised learning model, we'll give it labeled data. So we'll say, for example, this is a cube, it has 6 sides and it's shaped in this way. The model will then learn from that and it will be able to recognize cubes. Now, in unsupervised learning models, we'll just give the raw data. We won't teach it anything through labeled data. It will start to then look at these objects and then it will start to differentiate one another or group them based on similarity. And in reinforcement learning, it will learn by trial and error. So in this example, the robot's holding a cylinder. It will then put it into the cylinder hole or the square hole, and if it does it correctly, it will get a reward. If it does it incorrectly, it will get a penalty. So that brings us on to deep learning. Deep learning is a subset of machine learning, and it works in a similar way. You provide data, train an algorithm, and let it learn patterns. The key difference is the type of algorithm used. Deep learning is inspired by human biology, specifically the neurons in our brain. These neurons are mimicked by structures called perceptrons, which form the building blocks of neural networks. The real power of deep learning lies in the ability to automatically extract features. In machine learning, you'd need to define features manually. Take a car for example. You need to specifically explain the features or define the features of a car. Example, number of doors, wheels, the height. In deep learning, the algorithm figures out this for itself, layer by layer, without human intervention. So why is deep learning so popular? Deep learning shines in areas where machine learning struggles, like unstructured data. It's very good at working with images, audio, text. It also does well with large data sets. So the more data you feed the deep learning model, the better it performs. For example, let's say you're building a system to review job applications. In machine learning, you need to extract features like years of experience, the university attended, and so on. In deep learning, you'd feed the raw resumes into the system, and it would automatically extract features and classify candidates. This automation saves massive amounts of time. Data scientists often spend 60+% of their time on feature engineering. So deep learning requires or reduces the workload significantly for data scientists. So when do you actually use machine learning versus deep learning? I found this flow diagram online which I think perfectly encapsulates when you would use one over the other. So use it as a logical reference as to go through the flow and determine whether you need one model over the other. But to summarize, you would use machine learning for most cases. It's faster, sufficient for smaller structured data sets. However, deep learning does come in handy in certain scenarios. For example, if you have huge amounts of data, unstructured data like images, audio, and text, or you have complex patterns that machine learning can't handle efficiently. And finally, if you want to know exactly why you got the results that you did. So I think that covers off the main branches of AI. AI is the big picture. Machine learning is a method to achieve it. Deep learning is a specialized form of machine learning that excels with large complex data. Understanding these differences helps you appreciate how AI powers the tools we use every day. And that's it. If you would like to dive deeper into any of these topics, check out my other videos or message me on LinkedIn. The link will be in the description section below. And I hope you learn something new. Until next time, see you later.